If you're studying for your Algebra 1 final exam, then you're probably overwhelmed with just how many numbers and formulas you need to shove into your brain as fast as possible. So here are the 10 most important problems that you need to know how to do to get an A on your final exam. So here's the first problem that we'll be doing in this video. Here we need to solve for x in this equation. So the way that we solve for x is by isolating the variable. We need to take the letter x, which is a number that we don't know, and we have to basically get it by itself on one side of the equation. The only problem is that we have an x on both sides of the equation, and that just makes things hard. So we need to get rid of one of these. Remember that we can do whatever we want to this equation as long as we do it to both sides. And that's how we're going to get x by itself. So to get rid of one of these x's, for example, if I wanted to get rid of the 4x, it's being added to this side. So I can do the opposite of addition, which is subtraction, and subtract 4x from both sides. So these would cancel out, but actually I don't really want to do this because then I'm going to have negative numbers over here, and that's just going to confuse me. So instead, I think we should get rid of this minus 2x to avoid negative numbers. So the opposite of minus is plus. So to get rid of the minus 2x, I'm going to do plus 2x on both sides of the equation. So the negative 2x and plus 2x cancel out. And on the right side, we just have 9. But on the left side, we need to add these two together. So 4x plus 2x, 4 plus 2 is 6. So that's 6x. And minus 3, because we haven't touched the minus 3 yet. Now we only have x on one side of the equation. So our next step is to try to get x by itself. So we can get rid of this 6 or this minus 3. I usually prefer to get rid of addition and subtraction first before dealing with multiplication stuff. So let's get rid of the minus 3 by doing the opposite of minus, which is plus, and add 3 to both sides. So these cancel out. On the left side, we just have 6x, and on the right side, we have 9 plus 3, which is 12. And now we just have a one-step algebra problem. Remember that if you have a number and a letter next to each other, then that means multiplication, if there's no sign in between. And the opposite of multiplication is division. So to get rid of this 6, I'm going to divide out 6 from both sides. So these cancel out. On the left side, we just have the letter x. And on the right side, we have 12 divided by 6, which is 2. So that means our final answer is x is equal to 2. All right, here's another solve for x problem. We need to figure out what the letter x is equal to. But in this case, it's actually not equal to, it's a greater than sign. So this is an inequality. What are we going to do differently? Well, we're going to start by just solving it the same way. And then the inequality sign is going to make things different at the end. But for now, let's just solve for x. Now, I'm noticing a pretty important math rule that you'll want to make sure you know. This right here, when you have a number in front of parentheses, that is the distributive property. The distributive property says that we need to take this minus 3 in front and multiply it to both parts, to the x and to the plus 2. So let's go ahead and do that. So negative 3 times x, and remember it's multiplication because there's no sign in between this number and the parentheses. That always means multiplication. So negative 3 times x, we can't multiply a number and a letter, so it's just going to stay as negative 3 times x. And then here we have negative 3 times 2. Well, 3 times 2 is 6, and we have one minus sign, so the minus sign stays. Now, we haven't touched this minus 4, so that's going to stay there. And then the rest we haven't touched either. The 5, we haven't touched that, so that is going to stay as 5 as well. Now, I am noticing here that we have two numbers, and those are like terms because neither of them have a letter, so we can just combine them. So minus 6 minus 4. If you're ever confused about negative numbers, just think of it as money. You lost $6, and then you lost another $4. So in total, you've lost $10. That's minus 10. And the rest of the equation is going to stay the same because we haven't touched it yet. Now we just want to get x by itself, like the last problem. So I'm going to get rid of the minus 10 first because it's easier to get rid of that first. So I'm going to do the opposite of minus, which is plus, and add 10 to both sides. So the minus 10 and plus 10 cancel out. On the left side, we just have minus 3x, and don't forget the minus signs. And on the right side, we have 5 plus 10, which is 15. And we'll carry down the greater than sign as well. Now all we have left is multiplication. The negative 3 is being multiplied to x, so I'm going to do the opposite, which is division, and divide both sides by negative 3. So the negative 3's cancel out. On the left side, we just have x, and on the right side, we have 15 divided by 3, which is 5. and one minus sign, so the minus sign stays. Now notice how I'm not writing the greater than sign yet, and that's because this is the rule that's different when you have a greater than or less than sign. Whenever you multiply or divide by a negative number, you have to flip the sign. So this was greater than, now it's going to become less than. And there you go. Our final answer is that x is less than -5. All right, it's time to do some graphing. This might be one of the most important skills that you need to have for your algebra final exam, is being able to graph a straight line. So we have to graph this equation, 2y equals 3x minus 4. And I think the easiest way to graph a straight line is by using slope-intercept form, which is y equals mx plus b. So right now our equation is not in slope-intercept form, right? It's really close, but we do have a 2 in front of y. So we're going to have to get rid of that to put this in slope-intercept form. And once we do have it in this form, then we can just pull out m and b to find out all the information we need to graph our line. So the m stands for the slope, and the b stands for the y-intercept. So how are we going to get this equation into slope-intercept form? Well, to get rid of this 2, it's being multiplied to y, right? So why don't we just divide both sides of the equation by 2? And then it'll be in y equals mx plus b. So when we divide both sides by 2, the 2's cancel out. On the left side, we just have the letter y. But on the right side, we need to divide both the 3x and the minus 4 by 2. We have to divide everything by 2. So 3x divided by 2, well, I mean, that's just going to stay as 3x divided by 2. But just to make things less confusing, we can put the x on the outside. So we can write this as 3 over 2 times x. That's the same thing. And then it'll be in slope-intercept form, right? 3 over 2 times x. And then here we have minus 4 divided by 2. Well, 4 divided by 2 is 2. And we have one minus sign, so the minus sign is going to stay. And now we have our equation in slope-intercept form. We have y equals a number times x minus a number. And looking at y equals mx plus b, right? M is our slope. So our slope here is 3 over 2. And then b is our y-intercept. Now, you might say that our y-intercept is 2, but it's actually -2, because you notice how it says plus b. But here we have a minus. A minus is the same as plus a negative number. So our y-intercept is -2. So let's go ahead and plot this on our graph. Let's start with the y-intercept. The y-intercept is where our line crosses the y-axis. The y-axis is this big vertical line here. It's the up and down line. And the x-axis is our left and right line, our horizontal line. So our y-intercept is -2, which means that it's going to cross the y-axis at -2. Now, positive numbers go up and negative numbers go down. So if we start at the graph, we need to go down 1, 2 squares to get to where our y-intercept is going to be at -2. Now we only need 2 points to be able to graph our line. And we already have one here, the y-intercept. So to get the other point, let's use our slope. Remember that slope is equal to rise over run, which means that if our slope is 3 over 2, then our rise is going to be 3 and our run is going to be 2. So let's go ahead and plot that on our graph. Our rise is 3, which means that we need to rise 1, 2, 3 squares. And then from here, we need to run 2. So we're going to go to the right 1, 2 squares. And right here is going to be another point on our graph. Now you could do this as many times as you want. You could go 1, 2, 3, 1, 2, and plot another point here. But we don't need to do that. We just have 2 points. That's good enough for us. So let's go ahead and draw a line that connects these 2 dots. All right, I'm going to try to draw a straight line. I can't imagine this going well. Okay, I mean, it's a pretty awful line, but whatever. So there we go. We have our pretty terribly drawn line, and that is the graph of 2y equals 3x minus 4. Okay, here's another problem about equations of lines, but instead of being given an equation and graphing it, we need to write the equation ourselves. And we're going to do it with just this information. So all we know is that the slope is equal to -3, and that this line is going to pass through the point 2, -1. Remember that in a set of points, the first number is x, and the second number is y. So if you were to plot this on a graph, you would go 2 to the right and then 1 down. Now we do eventually want this equation to be in slope-intercept form, y equals mx plus b. But we can't just immediately write it in this form, because we do know what the slope is. The slope is -3. So that's what m is going to be equal to. But what is the y-intercept? Well, that's what y is equal to when x is 0. But x is not 0 here, so we have no way of knowing the y-intercept right now. So instead, we're going to be using a different form for our equation. And it's what you use whenever you know a point and the slope. Can you guess what it's called? That's correct. It's called point-slope form. It's very creative. So point-slope form is y minus y1 equals m times x minus x1. So you'll notice that we still have m, right, which is our slope. And we know that the slope is -3. So we can just replace m with -3 because we know that's the slope. But we don't have a b here for our y-intercept, and that's because we don't know what the y-intercept is. Instead, we have an x1 and a y1. Remember that in an equation, you always keep x and y as x and y, because the point is that you plug in numbers for x and you get numbers out for y. But x1 and y1 are going to be replaced with the point that we know, which is 2, -1. So let's go ahead and do that. 2 is the x coordinate. So we're going to replace x1 with the number 2. So we're going to erase x1 and we're going to put 2. And -1 is our y coordinate. So let's go ahead and erase y1 and replace it with -1. Now, I mean, this is pretty redundant here, right? We have -1, minus 1. Two negatives make a positive. So we can just write a plus sign instead of two minus signs. And there you go. We have our equation. But there is some stuff that we can simplify, and let's go ahead and try to get this into slope-intercept form. First of all, I see we have the distributive property here, right? So we can distribute the -3 to the x and to the -2. So -3 times x, that's just going to stay as -3 times x. And then -3 times -2. Well, 3 times 2 is 6, and two negatives make a positive, so that's going to be +6. Now on the left side, we haven't done anything, so it's just going to stay as y plus 1. And now the final thing to get this into slope-intercept form is to get y by itself, because remember, it's y equals mx plus b, and y is by itself here. So we need to get rid of this +1 by doing the opposite of plus, which is minus. So I'm going to subtract 1 on both sides. So these cancel out. On the left side, we just have y. On the right side, this -3x isn't being affected, so it's just going to stay as that. But then here we have 6 minus 1, which is 5. So it's going to be +5. And there you go. We have our equation in slope-intercept form. We have found out that the y-intercept is equal to 5 from doing this. So this is our equation. So here's another problem where we have to solve for variables. But instead of just solving for x, we have to solve for x and y. The only reason we're able to do that is because we have two equations. It's called a system of equations. If we just had one equation with x and y, we wouldn't be able to solve it. Now, when you're solving systems of equations, there are two main ways to solve it. There's substitution and elimination. Elimination is a little bit faster, but it's a little harder to understand. So for this problem, I'm actually going to use substitution. The goal of substitution is to take one of these equations and solve for one of the letters. And then you can take that, now that you know what that letter is equal to, and plug it into the other equation. So this bottom equation here, it looks like it's a lot easier to solve for a letter. So I'm going to use this bottom equation. I can get x by itself by just adding y to both sides, because minus y, the opposite is plus y. So let's add y to both sides. These cancel out. On the left side, we're just going to have x. And on the right side, we're going to have 3 plus y. You can't add a number and a letter, so it's just going to stay as 3 plus y. So we don't know what x is equal to in terms of like what number it's equal to, but we do know that it's equal to 3 plus y. So how can we use that to our advantage? Well, in this equation up here, the other equation, why don't we replace the letter x with 3 plus y? Because we know that they have to be the same. Then all we're going to have in this equation is the letter y and not the letter x. So I'm going to rewrite this top equation, but instead of x, I'm going to write 3 plus y. And I'm putting it in parentheses because we're going to have to do the distributive property on this, because it's 3 times everything. And then minus 2y equals 5, just like the top equation. So now let's go ahead and solve for y. I'm noticing we have the distributive property here, so we have to multiply to both sides. So 3 times 3 is 9, plus 3 times y is just 3 times y. And everything else is going to stay the same as it was before. Now I'm noticing that we have like terms here. We have two numbers here that have the letter y. So that means we can combine them. We have 3y minus 2y. 3 minus 2 is just 1, so we're just going to have 1y left. Now, whenever you have the number 1 in front of a letter, you don't have to write the number 1, because anything times 1 is itself. Then everything else is going to stay the same, so this 9, we haven't done anything with it. So 9 plus y equals 5. And now let's just get y by itself. The only thing in its way is this 9, and it's being added to y. So I'm going to do the opposite of addition, which is subtraction, and subtract 9 from both sides. These cancel out. On the left side, we just have y, and on the right side, we have 5 minus 9. So think of it as money. You earned $5, but then you spent 9. So in total, you've lost $4. And there you go. We have found out that y is equal to negative 4. But remember, we have to solve for x as well. So to solve for the other letter in a system of equations, we just need to pick one of these equations and plug in negative 4 for y, and then solve for x. So I'm going to use this equation because x is closer to being by itself. So I'm going to rewrite this equation, but instead of y, I'm going to write negative 4. And remember that this is pretty redundant. We don't need to have two minus signs, two negatives make a positive. So that's just going to be positive 4. And now we just need to get x by itself. So this plus 4 is in the way. I'm going to do the opposite of plus, which is minus, and subtract 4 from both sides. These cancel out. On the left side, we just have the letter x. And on the right, we have 3 minus 4. So you gained $3 and then you lost 4. So overall, you're down $1. So x is equal to negative 1, and that is the other part of our answer. So our answer is that x is equal to negative 1 and y is equal to negative 4. Or you can write your answer as coordinates. So remember that a point has x and then y in parentheses. So we can write it like that. We can have a set of parentheses, and then we would just write the x value, which is negative 1, and then the y value, which is negative 4. So this is another acceptable way to write your answer. All right, let's talk a little bit about functions, or f of x. Here we know that f of x is equal to 2 times x squared minus 1 plus 3. And our goal is to solve for f of 3. So a function is basically just the same as an equation. F of x is kind of just the same thing as y. You could graph this on a graph if you wanted to. But when we're solving a function, you'll notice that when we go from f of x to f of 3, we are replacing x with 3. So on the right side here, we're going to have to do the same thing. X is basically our input, the number that we're putting into the equation, and we want to find out what we get out for f of x. So let's go ahead and rewrite our equation, but instead of x, we're going to write 3 on this side as well. So f of 3 is going to be equal to 2 times, and instead of x squared, we're going to write 3 squared minus 1 plus 3. And now to solve this, we're just going to use our favorite math topic, the order of operations, or PEMDAS. Now, the first step in PEMDAS is P, which is parentheses. So everything in parentheses we need to solve first. So within these parentheses, we need to do the squared first, 3 squared. Well, that's just 3 multiplied by itself. 3 times 3 is 9, so that's going to be 9 minus 1. And everything else is going to stay the same. Now, continuing to solve what's inside of the parentheses, 9 minus 1 is 8. So we're going to have just 8 in parentheses now. So the parentheses are done. We don't have any more exponents. So now we have to do multiplication and division. And remember that in algebra, whenever there's not a sign, that means multiplication. So this right here is actually 2 times 8. 2 times 8 is 16. And now all we have left, we don't even really need to use PEMDAS anymore, but just because why not? Next is addition and subtraction. And here we have addition. 16 plus 3 is 19, which means that our answer is 19. That is what f of 3 is equal to. All right, this is another graphing problem, and this one is really important. We need to graph this equation, and then we need to find the domain and range. So it's a two-part problem. So first, how are we going to graph this? And what even are these things? Why is the x trapped in like a jail cell or something? Well, these lines are absolute value signs. And basically, absolute value is you just take the number and make it positive. So like the absolute value of 3 is 3, or the absolute value of negative 4 is positive 4. It's just the same number, but if there's a minus sign, you get rid of it. So how do we graph this? Well, we can use something called transformations, which is basically where you take a parent graph and then you figure out what the extra numbers are doing to it. So we can just graph y equals the absolute value of x, which is our basic graph that we can just graph the same way every time. And then we have to find out what is the plus 1 doing to the graph. So let's go ahead and plot y equals the absolute value of x. What happens when we plug in 0 for x? Well, we get out 0 for y. The absolute value of 0 is 0. So that's just the center of the graph, 0, 0, right here. Now, what if we plug in 1 for x? Well, when we plug in 1 for x, we get out 1 for y. The absolute value of 1 is 1. So when x is 1, y is 1. How do we plot that on a graph? Well, x is left and right, and positive numbers go to the right. So x being 1 means we need to move 1 square to the right. And then when y is 1, y is up and down. And positive numbers go up. So we need to move 1 square up. And then we're going to plot a point right here. Now, if we plug in 2 for x, the absolute value of 2 is 2. So we need to go 2 squares to the right and 2 squares up. And we'll plot a point right here. Now, what about negative numbers? If we plug in negative 1 for x, remember the absolute value makes it positive. So the absolute value of negative 1 is positive 1. So negative 1 for x is left and right, and negative numbers go to the left. So we need to go to the left 1 square. But because y is positive 1, we're still going to move up 1 square. And we'll plot a point right here. And if we do the same thing for negative 2, the absolute value of negative 2 is positive 2. So negative 2 for x, we move 2 squares to the left, and positive 2 for y, we move 2 squares up. So all of that is to say that our absolute value equation is a V-shaped graph. So we can just go ahead and plot that, and hopefully I don't do that terribly. I probably will though. All right, that's good enough, I guess. Oh, this side is a little longer. We need to fix that. All right, there we go. That is our absolute value equation. So what do we do now? What is this plus 1 doing to the graph? Because this plus 1 is being added to the absolute value of x. Well, we are taking whatever y is equal to, which is the absolute value of x, and then we're adding 1 to it. Whenever you add a number to y, it moves it up because y is up and down. So this plus 1 is moving the entire graph up 1 square. So the bottom of our graph is going to move up here, and then this point is going to move up here, and then this point is going to move up here, and so on. So we can now go ahead and plot our new graph, which is going to be 1 square above the previous graph. Bro, I cannot draw a straight line, bro. Okay, there we go. That's the best it's going to get. So we can erase our parent graph right here, the green one, because that's not actually our final graph. This is right here. So there you go. We have graphed our graph. We've graphed the equation, the absolute value equation. But now we need to find the domain and range. So what do those mean? Well, domain is basically all of the numbers that you can plug in for x. Range is all of the numbers that you can plug in for y. So what is our domain? What numbers can we plug in for x? Well, looking at this equation, it seems like we can just plug in whatever number we want. There's nothing stopping us from putting in any number. And the graph seems to say the same thing. This goes on infinitely in the left and right directions, so literally any number from the left to the right can be put into the equation. So the domain is going to be all real numbers. Now, what about the range? The range is all of the numbers that we can get out for y in this equation. So based on the graph here, can we get out any number for y? Well, y is up and down, and remember that these are going infinitely upward. So any numbers in this direction up here we can get. But what about down here? This whole area down here doesn't have any part of the graph. And so we can't get out that number for y at all. So we need to ask ourselves, what is the lowest number that we can get for y? Well, that would be right here. This is the lowest point on the graph, right? And that is 1 square above the center of the graph. So y is equal to 1 here. So 1 is the smallest number that we can get for y. So our range is going to be any value of y as long as it's greater than or equal to 1. We have to put this little line underneath the greater than sign. This line means equal to. So y can be exactly 1, or it can be bigger than 1. But anything less than 1 is not going to work for this graph. So there you go. This is the equation of our This is the what? This is the graph of our equation, and this is the domain and range. Okay, here's another problem that looks a little bit less scary than the last one. For this one, we need to simplify this expression. We have x plus 4 times 2x minus 5. Remember that there is no sign in between these two sets of parentheses, which means that it's multiplication. So how do we multiply these two together? Well, we can't just multiply the x parts together and the numbers by themselves together. That's not how it works, unfortunately. That's because we have two sets of parentheses, and each set of parentheses has a plus or a minus in it. So we basically have to do the distributive property, but it's like a more complicated version of the distributive property. So in this scenario, we can use a method called FOIL. The letters of FOIL stand for the different steps that we have to do to multiply these two sets of parentheses. The first step is F, which stands for first. So we need to multiply the first parts together. So this part of the parentheses and this part, the first part of each set. So x times 2x, well, 2 is the only number here, so it's going to stay as 2. And then we have x times x. Multiplying anything by itself is also called squaring. So we're going to have x squared. That's x times x. The next step in FOIL is O, which stands for outer. So we need to multiply the outer numbers together. So we don't have x times 5. Remember that it's a minus sign here, so it's x times minus 5. We can't multiply a number in a letter, so it's just going to stay as x times minus 5, or minus 5 times x. Next, we have I, which stands for inner. So we have to multiply the inner numbers together. So 4 times 2 is 8, and we have an x, so the x is going to stay. And there are no minus signs here, so it's going to be a plus. And then finally, we have L, which stands for last. So we have to multiply the last parts together. So 4 times negative 5. 4 times 5 is 20. And we have one minus sign, so the minus sign stays. Bro, this bug will not go away. So we've multiplied these two sets of parentheses together, but there is one more thing we can do to simplify. I'm noticing that we have a minus 5x and we have a plus 8x. Those are two parts that both have an x. So those are like terms, and we can combine them. So minus 5x plus 8x. That's the same as 8 minus 5. 8 minus 5 is 3. And we're adding two parts with an x, so it's going to stay as an x. And we haven't touched the rest of the equation, so that's all going to stay the same. Remember that this is a plus, not a minus, because it's positive 3x is what we got, so it's a plus. And there you go. There's nothing else that we can simplify. You cannot add together an x squared and an x that's not squared. Those are not like terms. It's got to be the same letter and the same exponent. So this right here is our final answer, 2x squared plus 3x minus 20. All right, let's talk a little bit about quadratic equations. That's an equation that has an x squared, an x, and a number by itself, and it's equal to 0. So we need to solve for x in this equation. Now we can't solve for x the normal way, because if we were to try to get x by itself, well, we have an x squared and an x, and remember we just said that we can't combine those. So there's no way that we're just going to get a single x by itself. So instead, we need to use one of our quadratic solving methods, and there's many of them. There's factoring, there's completing the square, there's the quadratic formula. I'm going to use factoring for this problem. Factoring doesn't always work, but I mean, I wrote the problem, so I know it's going to work. The goal of factoring is basically to do the opposite of FOIL, like what we just did. We want to turn this into two sets of parentheses that have x plus a number and x minus a number. So two sets of parentheses, basically turning our already FOILed equation into something that we would have to FOIL. So how do we find those two numbers that are going to go in the parentheses? Well, we just need to find two numbers that add up to the number in front of x and multiply to the number that's by itself. And you'll notice that I'm including the minus sign in those numbers. The minus signs are always included. So I like to try to find numbers that multiply to negative 14 and then see if they add up to minus 5. So what are some numbers that multiply to negative 14? Well, just ignoring the minus sign for now, right? Numbers that multiply to 14, the obvious one is 1 and 14. Now, because we're multiplying to negative 14, one of these numbers has to be negative. And I'm going to put the minus sign on the larger number because we are adding to a negative number. We know that the larger number has to be the negative one. If I had put the minus sign on the smaller number, then we would be adding to a positive number. And we're trying to get negative 5. So 1 times negative 14 is negative 14. But if we add these together, 1 minus 14, we got $1 and then spent 14. So in total, we are down $13. So we got minus 13, and we're looking for minus 5. So this is wrong. These are not the numbers we're looking for. What are some other numbers that multiply to 14? Well, 2 times 7 is 14. And remember that I have to put the minus sign on the larger number because we are adding to a negative number. So 2 minus 7 is negative 5. You got $2 and then spent 7, so you're down $5. And that is the number that we're looking for. We are looking for minus 5, which means that our magic numbers in this problem are 2 and negative 7. So what do we do with these two numbers? Well, let's go ahead and set up our parentheses again. We want to turn this into an equation that has to be FOILed, basically. So we're going to have x plus or minus a number times x plus or minus a number, and it's going to equal 0 because that's what it is in the equation. And these two numbers are just going to be what we put into the parentheses. So in this one, I'm going to put plus 2. And in this other one, I'm going to put minus 7. So now we're not just going to FOIL this equation, because if we do, we're just going to get this again. So instead, we're going to use a special property because this is equal to 0. Remember that anything times 0 is 0, and these are being multiplied together. So if x plus 2 is equal to 0, then we have 0 times whatever this is. It doesn't matter what this is, the whole thing is 0 because this is 0. Or what if x minus 7 was equal to 0? Well, we have whatever this is times 0, which is 0. So basically, if either of these sides is 0, the whole thing is 0. So there are two different possibilities that would make this equation equal 0. One possibility is if x plus 2 is equal to 0, then the whole thing is 0. Another possibility is that x minus 7 is equal to 0. And that would mean that the whole thing is 0 as well. So we've just split this up into two equations, and the only reason we're able to do that is because it's equal to 0. And quadratic equations usually have two answers. So to figure out those two answers, let's solve each of these equations. So in this first one, we have x plus 2 equals 0. To get x by itself, let's do the opposite of plus, which is minus, and subtract 2 from both sides. So these cancel out. On the left side, we just have x, and on the right side, we have 0 minus 2. The 0 isn't doing anything, so that's just minus 2. And there we go. We've solved for x on one answer. We have to do the same thing on the other side as well. So x minus 7, to get rid of the minus 7, let's do plus 7 on both sides. These cancel out. On the left side, we just have x. And on the right side, we have 0 plus 7, which is 7. So x is also equal to 7. There are two answers to this problem. X is equal to minus 2, and x is equal to 7. All right, for this problem, we have another quadratic equation. It has an x squared, an x, and then a number by itself. But we need to graph this quadratic equation. So whenever you graph a quadratic equation, it's always going to be a parabola, which is basically a U-shaped graph. It'll look a little something like this. Maybe not as terribly drawn as that, but something like that. So to graph a parabola, there are 3 steps that we need to do. First of all, we need to figure out the axis of symmetry. Notice how if I were to draw a line in the middle of this graph, then this is like a mirror image, right? It's symmetrical. This is symmetrical to this. The second step is to figure out where the vertex is. The vertex is the bottom of our graph, so right here. So once we know where the axis of symmetry is, then we just need to figure out where do we start our graph, where on this line. And then finally, once we have the vertex, we can do the final step, which is to figure out the rest of the points, and then just draw our graph from the vertex. So how do we find our axis of symmetry? Well, it's actually not that bad. There is a formula that you'll have to remember, but it's pretty short. The formula is negative b over 2a. And technically it's x equals negative b over 2a because that's what x is going to equal to on our vertical line. So if you're wondering what a and b are, well, another way you can write a quadratic equation is in the format y equals ax squared plus bx plus c. So basically, in other words, a is the number that's in front of x squared, b is the number that's in front of x, and then c is the number by itself. So what's the number in front of x squared? Well, there is no number, right? But remember that if there's not a number in front of a letter, it's an invisible 1. So a is going to be equal to 1, and we can just go ahead and replace a with 1. And now what about b? Well, b is the number in front of x, and in this case, that's negative 4. Don't forget the minus signs. So we can replace b with negative 4. But here we actually have negative 4 because it was negative b. So minus minus 4 is just the same thing as positive 4. And now on the bottom of our fraction, we have 2 times 1, which is 2. Now remember that fractions are the same thing as division. So this is 4 divided by 2, which is 2. So this is going to be our axis of symmetry. X is equal to 2. So where is x equal to 2? Well, starting in the center of our graph, x is left and right, and positive numbers go to the right. So we need to move to the right 1, 2 squares, and the axis of symmetry runs up and down. So let's just go ahead and draw like a little dashed line here to represent our axis of symmetry. So there you go. This is going to be where our graph is symmetrical. But now we have to do step 2, which is where on this axis, where on this line, do we need to start our graph? Where is the vertex, basically? The way we do that is we just use the formula that we just used. We found out that x was equal to 2. So to find out what y is equal to here, how far up or down do we need to go? Let's just plug in 2 for x and see what we get for y. So y is going to be equal to, and instead of x, we're going to write 2. So it's going to be equal to 2 squared minus 4 times 2 instead of x plus 3. So let's just go ahead and simplify this. Y is equal to 2 squared, which is 2 multiplied by itself. 2 times 2 is 4. Minus 4 times 2, which is 8. Plus 3. And now we just have to solve this left to right. So 4 minus 8, you gained $4 and then lost $8. So you're down $4. And then 4 plus 3. So you lost $4 and then you gained 3 back. So you're still down 1. So when x is equal to 2, y is equal to minus 1. So minus 1 for y. Y is up and down, and negative numbers go down. So starting from the middle here, starting from 0, we need to go down 1 square. So right here is going to be where our vertex is, the middle of our graph, the anchor point. So now our final step is to just plot as many other points as we can to get our nice U-shaped graph. So how are we going to find those points? Well, let's plug in the other values for x. This is x equals 2 here, right? So one more to the right, this is x equals 3. So let's plug in 3 and see what we get. Let's replace all of the x's with 3. 3 squared minus 4 times 3 plus 3. So 3 squared, 3 times 3 is 9, minus 4 times 3 is 12, plus 3. And 9 minus 12 is negative 3, plus 3. And negative 3 plus 3, that's the same thing as 3 minus 3, which is 0. So when x is 3, right here, y is equal to 0. So that means not going up or down at all. So that point is going to be right here, 3 to the right, and then nothing up or down. All right, let's go ahead and plot one more on the other side here. Let's go ahead and do x equals 1. So that's 1 squared to the right. So let's go ahead and plug in 1 for x. So we have 1 squared minus 4 times 1 plus 3. 1 squared is 1 times 1, which is 1, minus 4 times 1, which is 4, plus 3. 1 minus 4 is a negative 3, plus 3 is 0. This bug won't go away. So x is equal to 1 and y is equal to 0. So 1 squared to the right, we're not moving up or down at all. So I'm actually going to plot ourselves 2 more points. I'm going to plot x equals 0 and x equals 4, but you would just do it the exact same way. So I'm going to speed it up really fast. Okay, so once you have 5 total points, I think that's enough for us to graph our U-shaped graph. So let's go ahead and graph the parabola. Remember that this right here is the vertex, it's the bottom of our U-shape, and we're just going to try to draw it to the best of our ability. Okay, that was kind of terrible, and this is not even really touching the point, but anyway, this is the best we could do. So this right here is the parabola. It's the graph of y equals x squared minus 4x plus 3. So there you go. Those were the most important problems you need to know how to do to pass your Algebra 1 final exam. But I know that some of you are really going for that A, and you really want to study as much as you can. So what I would recommend is that you watch the Algebra 2 final exam review. Even if you're not taking Algebra 2 right now, a lot of this stuff is just a slightly harder version of what you're doing right now. So if you're really going for that A, then I would recommend continuing your studying with this video. Thanks for watching and good luck on your finals. You got this.